In one of my previous aviation videos, I briefly mentioned something about the Pitot static system on an airplane, and I received a few requests. From some students who want me to go a little deeper into the subject. And okay, let's talk about it. Pitot static system on an airplane. Okay, it's as you can tell, it is a dual system composed of Pitot tube or Pitot tubes and static ports. Those two, they work hand in hand. They could have been built in one piece because they have such a tight relationship, but that could not be done, and because of the specific location, each one of them has to be installed on the aircraft. The Pitot tube has to be installed in a position where it is facing directly the relative air, the airflow going over the wings of the airplane, because its purpose is to measure airspeed, is to measure the airflow, airspeed, and to measure the velocity, and to measure the aircraft speed. That's what the Pitot tube does, and the Pitot tube has a port. Okay, that's and we also have. So we can safely say that the Pitot tube measures dynamic pressure. Okay, because the speed of an aircraft, the airspeed of an aircraft depend on the pressure of the air pressure. So we have the Pitot tube. Okay, that measures the airspeed, the aircraft speed, and we have the static port that measure the static pressure of the air acting on the aircraft. So it's a dual system, you know. So there could not be the Pitot tube and the static port could not be located in the same, could not be installed in the same location. Each of them has to be installed in a specific location to be able to provide accurate readings of the air pressure and of the airspeed. So the static port must be located in a position in the aircraft where the local air velocity equals the velocity of the aircraft. Let me repeat that. The static port must be installed at a location where the local air velocity equals the aircraft velocity. So that's one of the main reasons why that even though the Pitot tube and the static port, they work hand in hand, they could not be located in the same location because they have different functions. So the Pitot tube measures the airspeed, the velocity, and the aircraft speed, whereas the static port measures the static pressure, or you can say just the pressure of the air. Okay, so the in the system there is something called a diaphragm. A diaphragm is a flexible piece, very thin, flexible piece that is that can be deflected by air. So the Pitot tube, okay, and the static port, they act differently on that diaphragm. And if you I can give you, since I'm also in the music recording business, I can tell you about I can use a metaphor using a microphone. Okay, in the microphone there's a diaphragm in the microphone, which is a thin piece, flexible piece, that when you speak into the microphone, the air pressure deflects that diaphragm in the microphone, and it creates an acoustic signal which goes into the microphone. And then down the line there's a magnetic field in the microphone that converts that acoustic signal into an electrical signal. Okay, but that electrical signal is very weak. Okay, they call it mic signal. It will get stronger when it reaches the mixer that you're using, and then at that time when that signal, that weak signal reaches the mixer, which is the mixer, in one channel of the mixer, then it gets more. It gets more volume. It is that signal becomes stronger because of because of the mixer that is now a line level input. So the line level is stronger. The line level signal is stronger than the mic level signal. So if I can use that metaphor in the Pitot static system, there's a diaphragm that air pressure deflects, and then that diaphragm, okay, the amount of deflection sends a signal to the IAS indicator. IAS, which is indicated airspeed in the flight compartment, and then the pilot can see the airspeed, the indicated airspeed of the aircraft. Okay, so but the only thing is, well, let me make a difference between the Pitot tube and the static port. The Pitot tube port, we can go ahead and call it a total pressure port. The Pitot tube indicates total pressure. Okay, so what I mean by total pressure is the static pressure plus dynamic pressure. That's what the Pitot tube measures. So when every time you hear about Pitot tube, think of total pressure. Static pressure plus dynamic pressure equal total pressure. Static pressure plus dynamic pressure, total pressure. That's what the Pitot tube measures. And then what is the static pressure? The static pressure is the static port does not measure dynamic pressure. Okay? The static port, I repeat, the static port on the aircraft does not measure dynamic pressure. But the static pressure, you need to remember the static pressure. I'm talking about the static pressure measured, at sea level. At sea level on a standard day. So the static pressure at sea level, okay, at sea level, acting on the aircraft is 2,116 psf. That's the static pressure at sea level on the standard day. When I'm talking about, every time I mention standard day, I'm talking about the standard day you can find like any other standard, like any other atmosphere standard condition on the ICAO atmosphere, on the ICAO standard atmosphere. Okay. So to return to the static pressure, the static pressure at sea level is 2,116 psf, okay, which is pound per square foot. This is that static pressure. So now we also know that when the air is free, okay, static, it is still. So at that point, the static pressure is 2,116 psf, and at sea level also the dynamic pressure, okay, is 34 psf. Okay, so the total pressure measured by the Pitot tube, okay, now is static pressure to 2,116 psf plus dynamic pressure 34 psf. That gives you 2,150 psf. So the total, so the pressure measured by the Pitot tube in order to determine the velocity, in order to determine the air speed of the aircraft, that pressure, the total pressure is 2,100. That measurement to 2,150 psf would deflect the diaphragm, which is very thin, so far, so the indication on the IAS in the flight compartment would not be accurate. Okay, so it would probably it would indicate, you know, a speed, you know, an excessive speed. So that's not good. That's not a good indication. Okay, so how do we get a good indication on the IAS? Well, on the IAS, and then of course, of course there will be some corrections on the CAS, calibrated airspeed, and then also EAS, which is equivalent airspeed. I know the mechanics, they know about that. So in order to find in order to get an accurate indication on the indicated on the IAS in the cockpit, we must find a differential pressure. Okay, how are we gonna get the differential pressure? Well, the differential pressure is going to be the dynamic pressure that will push, that will deflect the diaphragm, you know, proportionally, not too much, not too little, in order for an accurate airspeed is displayed on the IAS. Okay, now how do we get that differential pressure? Well, as the total pressure enters the center of the diaphragm, the static pressure, okay, is ducted around the diaphragm. Okay, not in the diaphragm, just around it. Okay, so you see the relationship between the two. The total pressure from the Pitot tube enter the center of the diaphragm, while the static pressure, which doesn't measure dynamic pressure, is ducted into the static pressure port, and then move around the diaphragm, but doesn't go into the diaphragm like the Pitot tube pressure, total pressure. So now what you do to get the differential pressure, now you're going to take the total pressure in the Pitot tube, which is 2,150 psf, minus the static pressure at sea level, the one that is going around the diaphragm, which is 2,116 psf. Okay, that will give you 34 psf. 34 psf. That's the pressure. That's the differential pressure that is going to deflect the diaphragm proportionally in order for the accurate indication, for the accurate airspeed indication is displayed on the IAS in the flight compartment for the pilot to see what's going on. So that's the way I understand the Pitot static system on an aircraft. So it is not that difficult to understand, but at the same time remember that. Also remember now, as the aircraft gains altitude, so what's going to happen? There's a lot of changes that are going to occur. Because the density of the air is reduced as the aircraft gain altitude. So that means the differential pressure will vary with altitude. Okay, so the Pitot static system is a very, very crucial system on an aircraft, and that's the reason why that the maintenance-wise, it is very crucial. It is very important for the system to be well maintained and to be well maintained and to be checked periodically in order for it to be in good condition all the time, in excellent condition all the time, because there's so many variables that depends on the proper operation of the Pitot static system. So I hope you understand. I hope I answered your questions about it. And then, by the way, that the Pitot static was invented by the French engineer Henry Pitot. Henry Pitot, or if I can, yeah, Henry Pitot. I think it was in the early, yes, it was in the early 18th century that Monsieur Henri Pitot, invented the Pitot Tube. But in the mid-19th century, however, it was modernized by another Henry. But this Henry was Henry Darcy. So, I hope I answer the questions that you asked me asked me in my inbox, and that's what I understand about the Pitot static system on an aircraft. It is a very important system. It's a system that tells you the airspeed of the aircraft, a system that tells you how high the aircraft is, and also the system that tells you tells the pilot when to make corrections, when to make corrections on the airspeed indicators. That's why you have the airspeed indicator that reads the airspeed indicator, IAS, reads the airspeed of the aircraft, but sometimes the corrections have to be made, especially when especially with aircraft that fly at high altitudes, where the Pitot Tube is subjected to ram air effect, and that ram air, when it enters the Pitot Tube, can deflect the diaphragm too far, which will indicate a higher speed than actually the aircraft is at. So that's the reason why the pilot, they have to make some corrections, and on the indicators, in order to have correct readings. So that's why you have airspeed indicators, IAS, then you have CAS, calibrated airspeed, and also you have EAS, equivalent airspeed, which is used usually after corrections have been made in both airspeed indicator and calibrated airspeed indicator, in order to find in order to measure true airspeed. So I hope you understand the explanations I gave you regarding the Pitot Tube system on the aircraft. And then meanwhile, stay safe and have a great day.